Hello and welcome back to KXAN Plus. I'm your host, Esmeralda Zamora, and today we have our space-based segment with our KXAN space expert, Eric Henrickson. Eric, thank you for joining me. How are you doing?
I'm doing pretty good. What day is the week? Is it Tuesday?
Tuesday.
It's Tuesday. I'm doing pretty good. It's Tuesday. I
early
got some
in
fun
the
stuff
week.
planned for my week, so we'll see what happens.
Last week, you had a pretty interesting week. Tell us what that was like.
Yeah, last week we took a look at dinosaur diets on our Friday newscast, and I worked on that story. It was really fun. Got to look at dinosaur teeth and play with giant dinosaur bones. I got to touch a bone of a Dilopithecus. I cannot say it. I said it one time while I was in the room with the paleontologist and have not been able to say it since.
Not much space news.
Not much space. Yeah, we're not going to feature that today, but you can check all those stories out on KXAN.com.
Still very, very interesting.
Very cool, very fun stories about the dinosaurs.
Well, today we're not talking about dinosaurs.
No.
We're actually talking about a supernova. What is that?
A supernova. So this one, I hate having to say these letters. 2021 YFJ, super memorable.
2021
That was
what?
when the supernova was discovered. So they name them by like when they're discovered, and usually it's like the satellite. But this is supernova 2021 YFJ. And what's fascinating about this supernova, this is an animation provided by the team that discovered it at Northwestern University, is it released layers of supernova.
Whoa.
And not just like that's an official sound effect like that. It wasn't just that, but they got to see layers of the star beneath. So there's this theory that stars have multiple layers to them, kind of like Earth, or a better analogy, like a cake, like a layered cake, right? So each layer could be something different. And they weren't quite sure what was on these lower layers. They know there was a hydrogen shell, it's like a hydrogen fondant. And then right beneath that was like an upper layer of frosting that was like oxygen and carbon. They found that, but they weren't quite sure what was in the lower layers. But what the supernova does is it explains kind of like what's down there. Steve Scholes with Northwestern University spoke with the Associated Press, and here's what he had to say about the discovery and what it kind of reveals.
We discovered a new type of supernova that is very, very different to anything we have observed before. And the data tells us that the supernova is connected with a star that has lost all of its outer layers, and it is essentially what was essentially produced by a star that was stripped down to this silicon sulfur-rich core. This is the first time that we have observed that such stars exist. It's the first time that we observe that also such stars can lose a significant amount of material, even though they are so already so stripped. And the other first is that these stars can produce brilliant supernova explosions that we can see from far, far away.
Super cool, right?
Yeah, that you can see from far, far away. It's crazy how we can capture that or see it through whatever tool that they're using and see that happen.
Yeah, these can be so bright that we just get this. You can actually see them sometimes in the night sky.
There's this sound effect.
Yeah, it's official. But sometimes we'll see like supernovas in the night sky. You'll see like a really bright light, and it could be a supernova. No, I couldn't say, oh, look, that's a supernova, but you might see something and go, that may be a supernova. That's how bright they get. So yeah, this kind of reveals like the different layers to these stars, and it basically these lower layers we found that closer to the core, it's silicon, and sulfur.
So many different types of materials.
Right. So the way stars work is it's a fusion of hydrogen and helium that fuel the star. And when hydrogen and helium fuse, they produce other compounds like oxygen and carbon. And I think last week we talked about how we're all made of stardust.
Yeah.
So the idea is like when these stars explode, they eject all that material out into the cosmos, and then they go into creating more things. Isn't that crazy?
That is crazy.
Yeah. So like think of a star as like a giant forge that's forging the building blocks of the universe. And then they erupt, they explode, they expand, something happens, sends all that material out, and then those atoms
create smaller versions.
They're used to build other things. So it's like these are creating the materials for the rest of the universe, all because of hydrogen and helium. And if you look at a periodic table, hydrogen and helium are 1 and 2. on the periodic table. So they're the smallest molecules we have, and so everything is built from those two fusing. Pretty cool, right? And so this discovery lets us know, like, hey, this is what's in the bottom of stars, and gives us a better idea of how things are made in stars and layers of stars and how everything is made. So it's always kind of like, whenever we talk about research like this, it's like, yeah, it's not going to impact you or me, but research is all about gaining knowledge that maybe eventually we can use it to understand something like fusion better. A fusion that could be used in the future to power the Earth. We can understand the byproducts of that and how if we mix hydrogen and helium, maybe we can create like sulfur and silicone, things that could be used in technology or other things. So it's like we learn more about these processes. We can maybe use these processes for ourselves, and also the pursuit of knowledge is always worth the pursuit.
Yeah, of course. And what do you know exactly what causes the stripping of these layers?
They don't know.
They don't know yet?
They don't know. There was a few ideas I read. There was possibly another star nearby that stripped the layers. So stars do go supernova, but without the stripped layers, all we see is the hydrogen kind of, and then everything kind of mixes and intermingles as it goes. But something had to strip the layers off the star before it exploded for us to see this. So there could have been a nearby star. One theory I read was that the gravity at the center of the star had become so great that things have been pulled down. And so the other layers just kind of didn't have things to hold them on. They floated off.
Yeah.
There could just be violent eruptions that are causing pieces to chunk off. They don't know. The quote that they used in their press release was that it was stripped to the bone. So the core of the star is its bone. Yeah. And so we get to see that. But yeah, they don't really know what caused it. So who knows?
And how frequent do these sightings occur? Is it rare? Is it frequently?
This is the first one we've seen this.
Wow.
They have seen stripped stars before. So with the hydrogen layer removed, so you can see the oxygen and the carbon beneath, but not this stripped down.
Wow.
Not stripped to the bone. See, it's first time.
So
cool, right?
In our lifetimes, first time.
We discover so much in our lifetimes. That's the fun part of this show. We get to talk about all the cool things we learned. And, knowledge is power.
Yeah.
I'm a G.I. Joe fan. So that's, Supernova. Pretty cool, right?
Yeah, extremely cool.
Awesome. Let's talk about SpaceX. They did a launch on Sunday. We'll keep this really short because it's just kind of simple, but there's the launch. I like looking at rockets go up into the sky.
How many launches come out of SpaceX in 1 month?
Oh, a month? 1 or 2, I would say. It's pretty common at this point. So this one's a resupply mission, so there's no astronauts on board. It's just bringing supplies up to the International Space Station. It's the Dragon spacecraft is the one they use, and it's the third resupply flight in the booster that use it. Third resupply flight for the capsule, which then will attach to the International Space Station and float down, and then the seventh flight for the booster. What I think is really cool about SpaceX's boosters is when they launch the capsule up into space, you'll see here, okay, it separates, right?
Yeah.
And then the booster comes back towards the Earth, and back in the day,
do they catch it, or does it just
catch it?
Kind
it
of
lands on. Actually, I think we should see it in this video. I'm pretty sure I saw it earlier. We'll see it in a second. It lands on I forget what that boat's called, but it lands on a boat out at sea. Oh, here I got it. It's called. This is a stupid name. I'm sorry. I shouldn't say that, but I think it is. It's too long of a name. A Shortfall of Gravitas is the name of the boat.
Okay, that is very,
come
very.
I'm not going to be too opinionated on this thing, but that's kind of that's not the best name.
No.
SpaceX usually has pretty cool names. That one's kind of bad. But yeah, you saw it land right there. So it lands on these drone ships out in the Atlantic, and then they were able to reuse the booster. This is the seventh flight of this particular booster, so it's launched up and landed 7 times. Pretty cool, right? And the third of the Dragon capsule, which will bring supplies up to the astronauts. And they changed the astronauts out last month, I think it was. It was last month they switched it out for us.
Do you know exactly how long the flight or the mission is going to take for them to take those supplies?
Oh, it's a 28-hour flight for the Dragon to go up there and connect. So it launched Sunday, so yeah, they already got the supplies. Already got new food, new water, all sorts of good stuff.
Nice.
Cake, maybe no telling what
Some layered cake.
Layered cake, why not? That's what you're going to do. You're going to do it right.
Yeah.
Finally, you want to talk about asteroids?
And our next topic.
Yeah, last topic of the day is the Bennu asteroid. Do you remember the Bennu asteroid?
I don't.
Okay, I got to talk about this a lot back when it launched. So OSIRIS-REx was this mission, OSIRIS-REx, right? Yeah. OSIRIS-REx was this mission we launched in 2020, and it was towards the Bennu asteroid, and it landed on the asteroid and collected samples, and then returned to Earth in 2023, which is 2 years ago, and it feels so long ago. But yeah, so this is this big mission. Can we recover materials from an asteroid? And they did. They were able to pull stuff off, and that's them with the materials that they got. That's OSIRIS-REx right there, and they were able, in the capsule, and they were able to pull stuff out of there.
And what did they discover from it?
Rocks.
Rocks? But anything about like the time those rocks were made or anything like that?
Yeah, it's the cool stuff. So these
I'm like, rocks?
Rocks. We just bring rocks back. So the rocks they discovered in Bennu, which circles through our solar system, orbits is the term. Orbits through our solar system.
Circles through our solar system.
Just circles through. It had materials in it that were older than the solar system, which is pretty cool, right?
Older than ours?
Older than our solar system.
Nice.
So the rock existed before the solar system did.
So it's
or at least
older
the materials
than we are, for sure.
Oh, yeah, for
Mankind,
sure.
I mean.
Yeah, for sure. Older than the Earth. Professor Sarah Russell with the Natural History Museum kind of broke down what they found, how they found it, and what the discovery means. And we can take a look at that right now.
Yep. Pull it up, and here it is.
What we've done is go through this material kind of grain by tiny grain, and we find some grains in there that originated in the inner part of the solar system near the sun, and they must have been thrown out into the outermost part of the solar system where the asteroid formed. And there are some grains in there that actually predate our solar system. They're older than the sun itself, and we think they came from ancestor stars to our solar system. And these kind of prove the point that we're all stardust. All of the material that went up to make the Earth and our bodies, all of these elements originally formed in stars that were ancestors to our solar system. So this has really kind of thrown up a lot of new questions about how our solar system formed. So what we found is that this asteroid, like a lot of other asteroids, formed right at the beginning of our solar system, 4.5 billion years ago. That's at the time when the sun and the planets were forming. And so they can tell us about the environment in which they formed. But one surprise was that this formed way out in the outermost part of our solar system. So they give us a chance to look at a part of our solar system that we don't normally kind of have access to, and that we can't normally visit very easily.
So the materials were found in the center of the solar system, ejected to the outer edges of our solar system, where they then formed into Bennu. So it's like you have like pieces that were thrown out there. But yeah, kind of. Guess where I got the video from, everybody? Sorry, that was on my fault. That's I left that on there on accident.
I thought I swapped it out, but
no. Sorry. It's my mess up. But yeah, so this contains materials from the center of the solar system that Bennu is formed on the outside, so it like ejected it out there. And like she said, it confirms the stardust theory. We always talk about how
we are all made of stardust.
Made of stardust, ancient stars in this case. Pretty cool, because unlike meteors that kind of hit our solar system or hit our Earth's atmosphere and they burn up, these are pure grains of dust from Bennu. And because of that pure grains of dust, we have a good look at what actually is in there. So OSIRIS-REx is able to get this stuff, take it back to the Earth in pristine condition. Pretty cool.
So we actually went out to get this material and bring it back. It wasn't something that we found here.
Nope. We launched OSIRIS-REx up there in 2020. It collided with the asteroid Bennu, and then it brought it back in 2023.
Nice.
Yeah.
Interesting.
Pretty cool.
How often do they do something like this?
This is it.
That's it?
That's the only one so far. Mm-hmm. We did do the DART experiment where we launched a rocket at an asteroid to see if we can move it.
Yeah. And
we figured out we could, and that was for asteroid collision prevention. How can I say that? How do we stop an asteroid from hitting the Earth?
Push it towards a different direction.
DART was the proof that we can do it. So if we hit the asteroid early enough, we can alter its course. It's kind of like, something, let me see if I can do this. If you have a rock coming in and it's coming straight, right? If you just go boop and just move it a little bit, it'll go this way in space.
Yeah.
Because all you got to do is just do a little shove. The cool thing about that mission with DART was it had two asteroids and they were orbiting each other. So by knocking one, we could tell by the changes in the orbit how much it's moved. Like we needed kind of like a point in space to measure that against. Yeah. And so that's what that point was. So you knock it a little bit and you can tell it started oscillating. And so if we did have an asteroid, we do have a system now to protect ourselves. How effective it is, we don't know, but we do know it works a little bit. And so, they're doing more tests. But OSIRIS-REx was one of its kind. Sending things up there, connecting with an asteroid in space is hard. Space is big, so you got to find an asteroid.
Finding the asteroid.
You have to match speeds, do all the things. You got to do all the hard part of landing on something.
Yeah.
On top of that, it is also big.
I think we did an entire episode on how they redirect the asteroids.
Yeah, we talked about DART, and because there was an update on it at one point that we did.
So we've done it in the past. It takes some time, but it's possible.
Yeah, and so we do more missions like this. I think one of the big ideas that there's out there is that we can eventually mine asteroids. So find out the materials in there opens up that business sphere. In the future, we could launch ships to asteroids, collect material, bring them back to Earth, or use them in space to build stuff.
So we're going into space, whether we like it or not.
I hope we do. That's, I'm very much an eggs in one basket kind of person. I don't like having every human being who ever existed
on Earth
in one basket. Yeah.
Really?
Yes. All it takes is one asteroid.
I don't know. I wouldn't want to be the human being that they send to space.
Oh, I would. I would be more comfortable if I could take, my family with me.
Yeah.
But
your pets.
Yeah, pets, husband.
What are they gonna do? Be floating around in space?
We've sent dogs to space before. I got 3 dogs. We could send 3 dogs. They've done it before. One of the first experiments. Actually, it was a really sad experiment.
That's what I'm saying.
But we sent a monkey there and back, so we can do anything. Early missions were sending animals to space, and then can we get them back? The Russians didn't care as much about getting them back, their early missions. So.
They just left them there?
Yeah.
So there's monkeys out in space right now.
Well, monkey skeletons. It was in the 60s.
Sad.
Sorry, guys. I'm just going to throw it out there. That was a few decades ago. Those monkeys aren't alive. This is sad, guys. I'm so sorry. They sent dogs. So we sent monkeys. They sent dogs. Yeah.
I don't know which one's better, but okay.
Well, we brought them back. So we're...
True.
Yeah. On that one, I think we win.
We got some morals there for sure.
Who knows? Yeah.
Well, this is the topics that we had for today. We also have your article that's on our website right now.
Yeah, let's look at the supernova core. I like that quote that the scientist gave us, stripped to the bone. What a great way to phrase that.
Stripped to the bone and all the layers in between.
All layers in between. The skin, the meat, the tendons of the star. The stuff, keeping that star moving and going. I don't know. I got a biologist in my heart somewhere, so that's where I come up with those.
Those slogans, those sayings.
Slogans. You know how we have that big old banner in the newsroom that says "right to the bone"? And just like that.
Well, this article is published and it's on our homepage at KXAN.com. You can find it pretty easily. You have some links in here as well as quotes.
Yeah,
right?
You want to read the full research paper. You know what? I will say this research paper was very legible. Most of these research papers I read, written for scientists. This one was written for I could read it, understand it pretty well. So if you want to check that out, it's worth a read. I thought it was pretty good.
Yeah. Well, thank you for joining us, Eric, and we will see you next week. For anyone that wants to catch...
Oh, no. Next week I won't be here.
No.
Yeah, I have a thing. So the following week I'll be back.
Okay. We'll have a plan for next week.
Okay.
But for anyone who wants to see similar videos like the Space Base, where can they download the app to do that?
You can download it on any platform, Apple TV, Roku, Android Fire Stick, and Samsung TVs, which is what I have. So that's where I have it now. So.
Yeah, and it's completely free. So go to the App Store, download that, and find some episodes of the Space Base or even more exclusive content that you didn't know you would find on there. Thank you, Eric.
Perfect. Thank you so much.